All right, guys. So right now we are still working on our unit of trigonometry. We're going to talk about angles of elevation and depression. The cool thing about elevation and depression is that you're either going to be looking up or you're either going to be looking down. So let's get started. So the first thing we're going to talk about is the angle of elevation. The angle of elevation is an angle that's formed by looking up from a horizontal line. So if you have a horizontal line, so we'll just draw a horizontal line. And from here, I want to go up. So you're going to look up from the horizontal line. So this angle here would be your elevation because you're going up from the horizontal. So this is elevation. Okay. And then your angle of depression is an angle formed by looking down from the horizontal line. So here's your horizontal line again. And if you look down from that horizontal line, so if you're going down from the horizontal line, this is depression. So this is the horizontal line of sight. Everything stems from there. All right. So here's your horizontal line. So if you're in this balloon and you're going to look down to the ground, this would be your angle of depression. So let's say you're looking down at a 38 degree angle. Well, if you're down here on the ground, so here is someone standing on the ground, they're going to have to look up in order to see the balloon. Now, if you'll notice, the angle of depression and the angle of elevation are both congruent to each other. That's because this horizontal line is parallel to this horizontal line. So these angles are congruent because of the alternate interior angles. So please make note that your horizontal lines are parallel, that the angle of elevation is equal to the angle of depression because of alternate interior angles. So horizontal lines are parallel. So that means the angle of elevation equals the angle of depression because alternate interior angles of parallel lines. All right, so here, when you're solving the problems, okay, so you have these diagrams. They're going to have angles of elevation and depression. They'll form right triangles. So to solve the missing links or angles, so if you have a problem, you're always going to begin by drawing a picture first. Then you're going to write the information that's given into your picture. Decide which ratio. Are you going to use sine, cosine, or tangent? Write that proportion, and then solve. Okay, so 5 steps to getting your answer. So let's practice some of those. So draw the diagram first. So on the observation platform in the crown of the Statue of Liberty, Michael is approximately 250 feet above ground. So if he's in the crown, he's right here. He is 250 feet above ground. So this piece here is 250. He sees a ship in the New York harbor. So here's the ship he sees. So think about it. Michael's here. He has this horizontal line of sight that he has to look out across. Okay, so he has to look down to see that ship. So he's looking down at 18 degrees. And they want to find the distance from the ship to the statue. So from here to here. So they're looking for this. Well, let me write this over here. So this is 250. Okay, well, if this angle of depression is 18 degrees, remember that the angle of elevation is also 18 degrees because of the alternate interior angles. So if this is the angle we're referencing, this is adjacent and this side would be opposite. So what function would I need to use? So some old called another. So there we go. So there's our SOHCAHTOA. So we have an O and an A, which would be tangent. So that means the tangent of 18 degrees is opposite over adjacent. So remember, when x is in the bottom, these two guys switch places. So x is 250 divided by the tangent of 18. So solving, typing it into the calculator, we find out that 250 divided by the tangent of 18 is 769.4 and this is in feet. And there's our answer. So we read the problem, we used what information was given, we drew our picture, and we solved. All right. A surveyor is 980 feet from the base of the world's tallest fountain at Fountain Hills, Arizona. The angle of elevation to the top is 29.7 degrees. His angle measuring device is at the same level as the base of the fountain. Find the height of the column of water to the nearest 10 feet. So you've got this fountain, and it says he is 980 feet from there. So he's 980 feet. So you've got this guy over here. And his angle of elevation to the top, so you start here at him and he's looking up because everything has to come from this horizontal, so he's going up, and that's 29.7 degrees. Of course, everything always makes a right angle with the ground. And they want to find this distance here. They want to find the height. So if I'm referencing this angle, this is adjacent and this is opposite. So SOHCAHTOA says, so SOHCAHTOA, I have an O and an A, so that means I need to use tangent. So the tangent of 29.7 is opposite over adjacent. So since x is in the top, I just simply need to multiply both sides by 980. So I can get x. So 980 tangent 29.7 is 558.98, but they want to the nearest 10 feet, so that is going to be 560 feet. Because 558 is closer to 560 than 550. All right, number 3. Number 3 says a blimp is flying to cover a football game. So you've got this blimp, and its pilot has a horizontal line of sight. So I'm going to draw the pilot's horizontal line of sight. He sees the stadium at a 7 degree, so here's the stadium. And he sees it at a 7 degree angle of depression. The blimp is flying at an altitude of 400, so that means it's 400 meters high. And it says how many kilometers, so be careful here because we've got meters and kilometers. So how many kilometers is the blimp from the point 400 meters above the stadium? So they're wanting to know this distance here. So if this is 7 degrees, if you have the ground here, you know that it makes this 7 degrees also because alternate interior angles. So using that information, if we're using 7 degrees, this is your hypotenuse, and this is opposite. So you would use sine. So the sine of 7 degrees is opposite over hypotenuse. So remember, when x is in the bottom, these two guys switch places. So x is 400 divided by the sine of 7. So x is 3,282.2 meters, but they want kilometers. So if you use your King Henry died by drinking chocolate milk, and I'm here at the base because we're at meters. Meters is our base. That means I have to go 1, 2, 3 places over. So 1, 2, 3. So x would be 3.3 kilometers. So that is how far the blimp is from the stadium. All right, number 4. A meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates it is 1,503 meters from her location. How high is the weather balloon above the ground? So they're looking for altitude. So I'm just going to draw a silly balloon. So here's my balloon. I know it says weather balloon, but we're just going to draw a regular balloon. And they want to know the height of this balloon, so I know they're looking for this. So if you think about, you've got a right triangle, and it says the angle of elevation is 41, so go to the horizontal and go up. So that's 41 degrees. And it says a radio signal from the balloon says that it's 1,500 meters from her. So if she's standing here, that means this is 1,503. So labeling, so we go this angle, this is the hypotenuse, and this is opposite. So I would need to use sine. So the sine of 41 is opposite over hypotenuse. So since x is in the top, we're just going to multiply. So this cancels, and we type that in the calculator, and we get that x is 986.1 meters. So that is the altitude of our weather balloon. All right, number 5. Number 5 says, one method that meteorologists use to find the height of a layer of clouds above the ground is to shine a bright spotlight directly up onto the cloud layer. So here's our cloud layer. So you'll need to draw this picture because I know it's not on your paper. So it says find the height of the cloud layer. So I'm looking for this. So if this is 35 degrees, this is my angle of elevation, and the measurement station is 525 meters away from the spotlight that's shining up into the clouds. So this is my angle, this is opposite, and this is adjacent, so I need to use tangent. So the tangent of 35 is opposite over adjacent. So I need to multiply by 525. So it cancels over here. And I find out that x is 367.61. And it says to the nearest 10. So 367 is closer to 370 meters. So that would be your answer. And we will do more practice in class. See y'all next time.